Alright folks, in this lecture we're going to talk about AB, or adhesive bonding. That's right, we're talking superglue folks, and all the varieties there are for attaching components. And keep in mind the majority of welding is all about combining parts or joining parts. That's what it's all about. And your typical adhesives can accomplish the same result. Obviously, strength may be in question in terms of comparisons, but there are a lot of advantages to adhesive bonding, and they are already a big part of the manufacturing process. So with bonding, you're still using joints. Could be a variety of different forms: butt joints, lap joints, T-joints, everything. So that doesn't make any difference whether it's welding or bonding. And one of the big advantages with this, or adhesive bonding, is we can throw in metals and composites and plastics, even wood. These are all different types of materials that we can actually use with adhesive bonding. Excuse me. Obviously, adhesive bonding can be used in the same way for manufacturing. It can be used in repair. It can be used, well, I guess that's pretty much manufacturing and repair, the key things there. One of the big things about adhesive bonding that we use it for in relation to not using welding would be, of course, for heat. Think about it. Obviously, welding produces heat and higher temperatures, which has sometimes negative impacts on the overall product. With adhesive bonding, typically you're not dealing with heat issues, and especially not dealing with heat distortion. Distortion is a problem that we run into with welding, and adhesive bonding we typically don't have that problem. Don't get me wrong, some actual adhesives do create a little bit of heat as a result of the chemical reaction, but nothing compared to welding processes. It also has the benefit of we may not need as many fasteners when we use adhesive bonds. We may be able to reduce some things there, and we may be able to reduce fatigue, and also we may be able to reinforce, when doing repair, joints that are about to fail with adhesive bonding. So super glue, obviously we're not really talking about super glue directly, but things like super glue and two-part epoxies and those type of adhesives can very much be useful to you in a lot of commercial applications. Obviously some high-grade stuff is planned to be used. So keep thinking that way. Actually, auto body uses a lot of adhesives. One of the advantages with auto body, again, is the heat. When you're dealing with these thin parts, when you throw a lot of heat to it, you can get distortion effects, but with adhesives, no distortion, and therefore no depressions that may occur in joining points. Thin metals. So if we actually had like a really thick piece of metal and we wanted to join it with a really thin piece of metal, we might have a hard time with the welding process. But with adhesives, we might be able to fill this joint and get it just right and join the two without much of a problem. Another big advantage of adhesives is the filler effect. So for example, let's say we're doing some kind of joint or repair work or something of that nature where we're going to be joining these two parts. Well, the advantage of adhesive is that the adhesive, typically in its form, is a semi-liquid and actually can fill up open gaps or depressions. So we can actually have a build-up effect with the adhesive bonding to create a better smoothness. So that's a neat feature. And obviously we have a lot more flexibility, in terms of joining. So instead of actually having to weld, use equipment, tight spaces, who knows what you're dealing with adhesive bonding we typically obviously don't have a lot of equipment, and we have a lot more flexibility in the applications that we can use them for. We do have some typical requirements for bonding. First of all, cleaning, or enough surface area. And that, of course, is respective to the type of joint and that sort of thing. But you have to have enough surface area to make it work. You also need to have clean surfaces typically. Most adhesive bonds require cleaning and surface prep. Maybe some sanding, I guess grinding in that case. And of course, applicable materials. Essentially meaning that the parts you're going to bond are rated for, or the actual adhesive you're going to use on parts is rated for those particular materials in question. The adhesive bonding process obviously can be manually performed. We do that all the time growing up in school and gluing things together manually, but it can be semi-manual, meaning assisted. It can be automatic in terms of robotics, can actually be used for adhesive bonding. So automation of the process is great because we can actually have assembly systems that actually provide the adhesive bonding. The actual chemical work that goes into play associated with the bonding component, depends on a lot of, I shouldn't say a lot of factors. The process itself can be initiated by several factors and resolved. For example, you go buy a tube of super glue and you open up the tube and you use it for a while and you don't clean the tube off very well and you put the cover back on. What happens in a couple days from now? You try to get that tube cover off and it won't come off. Well, that's an example of when we have evaporation. I'll just write that out there. Is the method at which the actual reaction takes place. So, until this is exposed to air, in the chemical or the fluid doesn't actually become hard and stiff until evaporation occurs. You can have your epoxies where they have a catalyst curing component where they have two parts. You have to mix part A with part B if you've ever used like JB Weld and that kind of thing, and that forms the catalyst that resolves in the bonding. Ultraviolet light can be a component to the process. Heat and pressure can actually be a event that triggers the reaction that creates the bonding. And both heat or pressure, I should say, or heat and pressure. So it just depends on the particular bonding agent, how it operates, and how it creates the reaction that creates the bonding effect. One of the things that you have to understand about adhesives is a little term called viscosity. Viscosity is a term that we use, especially if you actually deal with oils or maintenance. You're probably used to the term. Viscosity is the term for resistance to flow. And what it basically means is, resistance to flow is sort of like this. If I take a container of fluid and I open the cap and here's that much fluid's in it, the speed at which it flows out of the bottle is a measure of viscosity. So high viscosity means that it is highly resistant to flow, which means that if this were a high viscosity fluid, it would flow very slowly. Molasses, for example, is a high viscosity fluid. Now, compare that to a bottle of water. That's a horrible bottle, but you get the idea. Fill it with water, and it has low viscosity, and you roll it out and you flip it upside down and it just floods, right? It has no problem flowing. So that's one of the things that viscosity, some people get confused on, is high or low viscosity. High viscosity means high resistance, low viscosity means low resistance. Water's low, molasses is high. So if the adhesive bonding agent that you're using was a high viscosity, it might be a gel form, which is doesn't really flow into place. You have to kind of push it there. Or there can be plastic-like forms. Plastic. I don't know if I want to do it this way or not. How about plastic-like? So a high viscosity gel, plastic-like, you have to kind of form it, shape it. Concrete that doesn't have a lot of water content will be a high viscosity. Fluids like super glue or trying to think of another one that would be, I guess your typical wood glues would be a lower viscosity because they are actually more liquid-like or semi-fluid, and they're easy to squeeze out of tubes. So just keep that term in mind and make sure you understand which way is which. High viscosity, high resistance. Molasses, low viscosity, low resistance, water. And that'd be a good comparison there for you. I do have a quick chart that comes in real handy. And check it out. This is a quick little graphic that actually gives you a pretty good sense of different types of adhesive bonds and some of the benefits of them For us, we're obviously talking about things that work well with water, so metal bonding, or I'm sorry, work well with metal, not water. Metal bonding would be a good feature for us to be thinking about given the nature of this class. So we might be thinking about things that are bonding with, that are good properties. So these are ones we might pay attention to. Probably not going to be worried about the poor to fair versions. So let's take a look. Acrylic can bond with metal. Cyanoacrylic, I think that's actually what super glue is. Epoxy, we use that a lot. That's usually typically very strong. We use that epoxy, two-part epoxies in construction. Polyurethane, obviously used in construction as well. Polysulfide, and solvent-based stuff. Some of the best results we've had out of like metal bondings have been two-part epoxies. And typically, two-part components have a very, if they're two parts for a reason that you don't want to mix until it's time to use, that implies they have some good strength to them. Look at the components for acrylic. You got two-part or one part that can be combined into two. Cure time, that may or may not matter to a person. Obviously, super glue is fast, and that helps when you're holding the parts together. But typically, if you're going to do something a little bit more rigid, more solid, more built to last, you're not going to necessarily want to rush that process. Epoxy is a slow to medium, it is, but it works out really well. Viscosity flows. So these are mediums, which means they actually either flow kind of slowly. In this case, epoxy is actually very resistant to flow. You have to work with it to get it where you want to. Polyurethane's medium, polysulfide's high. Never actually worked with polysulfide. Apparently it has good void filling capacity. And these other factors of, are they resistant to heat? How flexible are they? How much cold resistance? How much thermal resistance? And let's see how these pair out. So the epoxy, for example, it does good in heat and good in thermal. Not necessarily great with flexibility. Acrylic looks to be a very good material in the fact that it bonds with metal, it's good water resistance, good heat resistance, medium viscosity, and good on void filling. So obviously acrylic adhesives are a good choice for real world selections. Look here at polysulfide. It has an excellent thermal resistance. It does have high viscosity, medium cure time. Silicone's great, but not that great with metal. So some of the things that actually would work really, really well with metal and have good properties, polysulfide, if I can just behave, polysulfide. Don't like the water resistance in terms of polyurethane, solvent-based, but that's actually not that great filling. So it looks like acrylic, and acrylic does well. Not too, these are okay. No, we're not going to worry about our super glue. Epoxy's pretty good, and polyurethane, okay. Polysulfide's good. So I guess in the metal category, the acrylic's probably the top dog here. So anyway, this kind of information is very, very important to folks that are actually working on repair work or even trying to reinforce manufactured products. We actually rely on this a lot when we use with some of our plastics work and metal bonding, because we actually do 3D printing with metal bonding components. So the acrylic and epoxy components are actually good for us to work with. Things that are easy to clean up are also really nice too, just saying. But this is your bonding is a big part of your work and what you do, so you want to take advantage and just kind of understand the technology other than just go buy something to put on there. You want to do a little research and what works out really, really well. So anyway, although we're typically dealing with welding, adhesive bonding is a big part of manufacturing processes, and especially on repair work and reinforcement work. Has a lot of advantages to keep in mind. All right, so that's that on that one. So, well, actually, one other thing, like especially if you go in the automotive industry, you'll probably see a lot of bonding, mainly because you have just so many different parts, processes, and you have a lot of thin materials. So, adhesive bonding works out well for that. Okay. So anyway, that's it for this one. We'll see you next time.